Hi, and welcome to the 10 square meter workshop. I have this theory that anyone who dabbles in machinery sooner or later makes two things. The first is a steam engine, of course, and the other is a model cannon. The usual choice is a naval cannon, such as this. There are plenty of examples. You're not going to get called out on a detail error, there were so many of them, and it's well understood. And of course, there's not too much woodwork involved. I've always been more interested in field cannon, especially that of the Napoleonic era. Much more complex, of course, literally hundreds more parts. But hey, more parts means more fun. Something like this. The full complement for something like this is shown here. Quite a lot. One advantage is that cannon of the Napoleonic era were made to a system, and there are images of the original drawings available. This makes it a lot easier. Well, enough talking, let's get started. And of course I'll start with that interesting part, the barrel. The barrel will be made from bronze. I have this piece of old yacht propeller shaft given by a friend. The barrel is a pretty straightforward turning job, although it makes an awful lot of chips. The only moderately tricky part in this is turning the ball end. I tackled this by doing as much as I could in the original between centres turning. I then reversed it, put it in a 4-jaw chuck with lots of packing and set it for 0 run out. Fortunately, the axial axis is not terribly important when you're turning a ball. After turning to length, I used a forming tool to make the ball shape. That's the barrel made. Now I need to add the trunnions and the dolphins. Gripping something like this can be tricky. I ended up using carefully measured aluminium shims, and to make sure it's horizontal I used a transfer punch and a level. The ball, of course, is my one true reference. I used a 5mm dowel to touch off the front and back sides of the barrel, and then halved it to get the centre. The x-axis is of course by measurement. After centre drilling, a 4mm pilot drill was put all the way through. If it seems a bit sacrilegious to be drilling right through a barrel, this is a model. It will never be fired. I will of course clear the bore once it's in. After using drills up to 10mm, I finish off to the 17mm size using a boring bar. With the hole cut, I can now make the trunnion that goes through it. This is a fairly simple turning exercise, using more of the prop shaft. A lot of material to remove to get down to 17mm, but fortunately you can be quite aggressive with this material. It's just over 17 now. I want an interference fit, so I'm going to take it down carefully. Fortunately the end of the trunnions are smaller, so I can afford to take small bites out until it fits. I found interference fit. It's 1706. Not bad considering boring bars aren't all that accurate. With one end bearing formed, it can be parted off, so I can do the other end. With both ends turned, I can now press this into the barrel. And here it is, ready to go. Fingers crossed. Moving smoothly. Need just a little bit more room. Right, change of packing pieces. Move it a bit further. Well, that looks to be about it. Need to measure it. With the trunnion in place, I can move on to the dolphins. These are the lifting handles. Fortunately by this period they were no longer formed in the shape of a dolphin. Not quite sure how I'd have done that. As you can see on the drawing, it's just a simple U-bracket. I shall be using the same material, and I'll use this offcut from when I turned the barrel to make these. I shall be making them as a pair in the form of a square. So the first job is to face off as usual. And then bored a 15mm hole. Not all the way through, not needed. And that concludes the lathe operations. Now into the mill, and the first job is to find the centre using the edge finder. Everything will be referenced to the centre. That stage is not super critical. There's no reference to the actual outside of the piece. Next stage, I'm going to take a light dusting over the top. I'm not going to rely on such a short stubby bit being absolutely square from the lathe to the vise. 50 microns got it squared off, and now I'm ready to follow a DRO map. Here it is with one pass around the outside of the rectangle. As you can see, it only just fits. Sometimes fortune smiles. And here it is after taking down the outside to 5mm. And here we are with the inside also milled out. Ready to part it off now. I rounded the outer corners by file, then removed it using the crude power of a hacksaw. Set on parallels, I can now thickness it. Machined to thickness, I now have a 2.5mm square section. The actual result needs to be octagonal, and I could mill that, but I think I prefer the control of doing it by hand. And this is it, filed octagonal, ready for separating. Split in two and mounted on a known height parallel, I can touch off the vise and finish the ends with pegs to fit into the barrel. The result is a 1.5mm square peg on each leg. Securing an item like this for machining is not easy. The method I used was a lot of packers, then I measured across the trunnions to get the right angle. 30 degrees, and that is about as accurate as you can get. This of course is the critical dimension. For the x-axis I used an edge finder on the front of the trunnion. If you can think of a better way of setting up for this, why not put it in the comments below. I could now centre drill my two holes 17.5mm apart, followed by a 2mm drill just over 3mm deep. With that done, I can move to the other side. With the 4 holes looking good, the plan is to knock the corners off the square pegs so they're a tight fit in those 2mm holes. And there they are mounted. It's looking pretty good, but now I'm going to put it all at risk by brazing all those parts on. I've supported the barrel on concrete blocks, ready to apply heat. I shall try and film this, but arms and things might get in the way. As expected, filming didn't go too well, especially as the granite blocks, which weren't as dry as I thought they were, started shedding bits at high velocity. Anyway, I managed to get it brazed and, as you can see, fairly well cleaned up afterwards. That took a bit of time. Next step is to patinate it. This is another one of those modelling decisions. Do you want it nice and shiny, or do you want it more realistic? I chose the latter route. Here it is, halfway through. I'm using a patination fluid that's really meant for lead. It's really meant for lead on stained glass windows, but it works very well on bronze. It's a rub it on, rub it off type technique, with using a small paintbrush for inaccessible parts. You have a lot of control. It takes a bit less than a minute to fully stain. You could go for super authentic, or having rubbed areas. where ropes etc. would go through the patterner. Well, that's the first module of many made, and I'm very pleased with it. Why not subscribe so you don't miss further episodes? That's all for this time. Bye for now.